Applications of classical mechanics. Classical mechanics deals with the motion of bodies when the bodies are acted upon by forces and applies to modern life objects like cars. In investigation of classical mechanics, different types of motions are studied. Translational, rotational, and oscillatory and circular motion are the different types of motion. Transitional motion, a body shifts from one point in space to another. Rotational motion is rotation around its own axis. Oscillatory motion, an object repeats the same movement over and over. Circular motion, rotation in a circular path. In order for it to be classified as classical mechanics, the object must move slower than the speed of light, but have a greater size than 1 nanometer.
Applications of classical mechanics. It can be used in astronomy as astronomical objects, as spacecrafts, planets, stars, and galaxies, such as an asteroid when it hits a planet, we can calculate that, or the period it takes for the rocket to land to the moon. It's used in chemistry as in particle collisions, as conservation of momentum is used in that. Geology, it's used in earthquakes to calculate seismic graphs where oscillatory motion is used. Engineering, cars, bicycles, and planes all use classical mechanics. And engineering is more of classical mechanics as it's a small object but slower than the speed of light. The topic of interest we chose was in airplanes or aerodynamics in this category. We chose aerodynamics or planes because of how they fly. Because they have wings and it looks like they should not fly with how heavy it is, and they have no force that is exerted by the airplane by itself to give it a vertical uh, motion. Uh, as it only has propellers in the horizontal direction, but as we find out sooner, it's the thing that makes it go up. And it's instrumental in people's life as we use it very often, but we do not know how it works.
According to Bernoulli, by the Bernoulli principle, an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. The wings on an airplane are called airfoils. They have an arch shape because it helps them able to lift and normally have an angle of attack of about 6 degrees. Their viscosity or air friction that allows the airfoil to be able to fly, allowing the lower half of the airfoil to experience greater pressure on the bottom than at the top. A simplification is more velocity equals less pressure and more pressure equals less velocity, as well as Bernoulli's equation and a visual representation of a wing going under air motion. In order for the plane to fly, it needs to generate lift. This is done by a combination of Bernoulli's principle and Newton's third law. We know that by Bernoulli's principle, the velocity of the air is greater on top of the wing, which causes a difference in pressure, with the bottom half having more pressure than the top. This causes a downward force on the atmosphere, and by Newton's third law, this causes an upward force on the plane.
The Wright brothers are the ones who created the first flight, as they used wing warping for lateral motion and controlling, as they had pulleys and cables to twist the edges of the wings in opposite directions. They used the centripetal force to make it move in a circular path. Yeah.